proportional relationship. The problem says a website contains hundreds of different recipes included, with each recipe is a table that gives the approximate cost for different numbers of servings. Find the unit cost for this recipe, then write an equation for finding the cost of X servings. So take a look at this graph. This table. Like, what do we know? What is it telling us?
So in 7th grade, you worked with unit rate. You were able to find it. Right? In 8th grade, we go one step further. You're going to use the unit rate. Now you're going to actually create equations with the unit rate to kind of show that relationship. So you'll be able to do a unit rate in an equation. You'll be able to graph an equation based on its unit rate, and you'll be able to create a table. That's really our goal for proportionality and unit rate. Sorry.
So we can use this graph to represent proportional relationship. So are these telling us the same thing? Is this table and this graph saying the same thing? What is it telling us?
How did we get that graph from the table? How did we get from these values here to these points here? How did we do that? What do you think? How did we get there? Okay, so the table is kind of telling us where to put the points. What did we first, if you're looking, pretend like you created the graph. What did you do to create the graph? What do you first need to identify?
The
The
x-axis.
x-axis and the y-axis. Which values will be on your x-axis and which values will be on your y-axis. And then from there, what happened with the table? What they do? How'd they get it on the graph? They determined that the x-axis is what? The number of servings. Go to our x-axis, that horizontal. And the y-axis is what? The cost. So then what?
So then from the table, they use the numbers from the table to plot the points based on the x and the y.
So give us an example.
So like four and $5.
Okay.
So from the number of servings, since it says 4, the number of servings, you go to the number 4.
Good.
And then since the cost is $5, you go up to the number 5. Since $5 is on the graph 5.
Good. So what is that coordinate? If you had to give the value of that coordinate that Manny just pointed out, what's the coordinate there? That coordinate that's in red. What's the coordinate? If you had to identify just the coordinate on the graph. How do we write a coordinate? 4, 5, because when we represent our coordinate, it's our x value and then our y value. Good.
So how do you know just by looking at this graph that it's a proportional graph?
Is that it?
There is a
That's a big one. That it's a straight line. It's like the first thing we look at. Giselle is 100% right. Let's add to that. It goes through 0. Good.
Awesome. So this point right here, 0, 0, what is that also called? The origin. This one right here is really, in proportional, every proportional graph is going to go through that point, the origin, 0, 0.
Can you explain why this scenario has a coordinate at 0, 0? This scenario specifically. The website, the number of servings for the meal, and the cost. Why would that go through 0, 0? Because some of us don't understand, like, why this proportional, why does that have to go through 0, 0? Why does this situation have to go through 0, 0?
Because Because if you have $0, you'll have 0 servings.
Good, and you can even say it like the other way too. Zero. If I'm gonna make 0 servings of this recipe, I'm not gonna make any of it. How much money am I gonna have to spend? Nothing, right? So that's That's why that would be the origin in this scenario.
Okay, so we can use an equation to represent a proportional relationship. So how much would one serving? So it tells us right here, 2 servings, 4 servings, 6 servings, 8 servings. How much is one serving the recipe cost? $1.25. How do you get that? Well, besides what it tells us on
So
the
it's
graph,
given to you on the graph.
what's another way that you could figure that out if it wasn't given to you on the graph?
Because you know 2 servings cost $2.50, so you
Uh-huh.
divide that by 2.
So you divide that by 2. Good. So you know two servings cost $2.50. We divide that by 2 because we want to find one serving.
So if this table had the value, it would be like right here. And when you're finding the unit rate from a table, it's okay if you need to put that in to like show, okay, this needs to be one serving. This is the calculation I'm going to do to get there.
So what is that? What is this one serving calculus? What is that called?
Or
what else?
Good.
The constant proportionality degree. So you can divide any of the ratios on the table. So any of these. So we tried this one. We did this one. We divided by 2, and we got 1 over $1.25. If you do that to any of these, you'll get they'll all be equivalent, and you'll end up with the unit rate or the constant proportionality. So what do you think the equation for this graph would be?
For every 1 serving, for every 1 serving, the cost is $1.25.
So he started that out really well. He said for every 1 serving, it's going to cost $1.25. So let's say that X is our number of servings and Y is our total cost. How would I write that in an equation?
That's our x-axis and that's our y-axis.
X equals 1.25 1.
Write that down. X equals 1.251. So let's see if this works. If I substitute in 1 for X, meaning 1 serving, how do I calculate Y? Is that going to make sense?
So y is our cost.
So then to solve for Y there, the equation that we're continuing, we would have to divide both sides by 1.25. Is that going to give us the value we need? No. Can I rewrite the equation a different way?
Y equals 100. Not 100. 1.25 X.
So let's look at that equation. If you had to say that equation in words, so instead of like a Y and an X, we're going to just say what it represents. That equation would be the cost equals $1.25 times the number of servings. I just read that equation, and instead of Y and X, I just replaced it with what it represents. The total cost is $1.25 times the number of servings. Does that make sense? Could I substitute values in for X to figure out Y? Would it match my graph?
Okay, so that's our equation. How can you tell by looking at the equation that it represents a proportional relationship? How can you tell that this is a proportional relationship with this equation?
So we already talked about, like when you're looking at a graph, how you know that it's proportional. If that it's a proportional relationship. If it's a straight line and it goes through 0. How can you identify just by looking at the equation?
Oh, no, I was going to say if you look at the chart, you can check if the other parts aren't true.
Let's just look at the
Just
y
at-
equals
just at
one
the
point two five x. Because there's stuff in there that kind of tells us the same things that the graph would tell us. We just gotta find it. How can we tell by looking? What do you think?
Because whatever you plug in for x, it will be multiplied by the same value to get y.
Okay, so we see that there is a constant rate. Is that all? Because that would relate to the straight line, right? The constant rate would equate to a straight line on the graph. But is that the only thing that tells us if a relationship is proportional? What else tells us if a relationship is proportional? If the line is straight, but what else? Go ahead.
Oh,
Sorry.
I think it's when you, but this is what Emmanuel said, like you keep changing it and seeing if it keeps following the same thing that it's saying basically, instead of it changing like a pattern would.
Right. Okay. So I agree with you, and that's really what's going to make it a straight line, right? The fact that the growth is constant. But is that the only thing that makes it proportional? Just a straight
Do you
line?
remember when we asked about the graph and Giselle said, we know it's proportional because it has a straight line, and then we said, yeah, that's true. But what else?
But what else?
It's like that zero.
It starts at zero.
Goes through.
It goes through the origin. It goes to the point 0, 0. So how can we check that this equation is proportional?
By putting x at zero.
Just that?
Because what happens if x is 0?
Why?
Why is it?
Y 0. Okay. And then it would equal 0 equals 0.
That is a key component of a relationship being proportional because you are going to see many equations that aren't, especially in functions. A lot of them are not proportional, and you'll see the difference quite quickly. Right now, that's your method, and then you may discover others as you start looking at equations. You may be able to tell without substituting a value, which you will eventually be able to tell without substituting if it is proportional or not. Some of you may get there a little bit sooner, but we're going to get there as a group at some point.
So the two ways that when you look at a graph, you can tell if it's proportional is knowing that it's a straight line and seeing that it goes to the origin. So those are the two important things that you have to remember about proportionality on the graph. Okay, so how is the unit rate shown in all three of these? The graph, the table, and the equation.
Because you need to be able to find the unit rate in all three. Because the unit rate is essential in creating an equation and graphing. So we need to be able to find it. How do we find it in the table? How do we find the unit rate in the table? Yeah, we want to
Oh,
find
we
the
wanna
value for 1.
So yeah, we want to find the value for 1. And we said we could divide any of these. We divided this by 2, got $1.45. Awesome.
How about the graph?
If you had the point 2 and 2.5, all you had to do was divide by 2.
Okay. Because on the graph, where is the unit rate on the graph? At what's 1?
1.
So for that graph, we're looking at when the x-axis, when it's at 1, that's my unit rate. And it just so happens that y is 1.25. Good. How about in the equation? How do we find the unit rate in the equation? It's not a trick question. Anybody else besides Luz? Do we have to replace the x with 1 to just see it?
Not really,
Why? What is the unit rate in that equation? How do we find it?
because you already know that 1.25 times 1 is already
So if I'm looking at any equation, how can I find the unit rate? Like if I'm just looking at it.
You can look at the number that's multiplying by x.
Okay, what do we call that number?
Coefficient constant.
Right, so well, yeah, another word for unit rate is our constant of proportionality, but Mortimer, you were kind of where I was leaning. That's the coefficient. The coefficient of our x variable right there is our unit rate here.
We already said what the constant proportionality is, right? 'Cause that's our unit rate. How do we find the slope of a graph?
How do we find the slope?
Does anyone remember how to find the slope?
We've done it. How do we find the slope? Raise your hand up. How do we find the slope?
The slope is basically based off your unit rate. It's kind of like how many spaces you go off your x and how many spaces you go up your y, which is basically your unit rate value.
How is it basically my unit rate value? I like where you're going.
Because if you go across one
Okay.
and you go up 1.5 and you get 1.25 and you go across that same thing again, you get 2 and 2 and 2.25. If you go up it again, you find 3, which is basically your next point. But since we already have 4, 6, and 8,
Right.
the slope is gonna find 3, 5, and 7.
If you had a point and you were given a slope, how do you graph it? What do you remember when you graph with the slope? What do you remember about slope? Let's just anything you remember about the slope.
You never really I just got it from learning that one day.
What?
I learned it from learning that one day.
Okay.
I don't even know. Isn't that that slope that road? I said shit.
So a slope is how you graph a line. So from one point, we could say our slope is how much our line is growing. Right? For every unit, how much is it growing? And in this scenario, what do we know about the growth? For every one serving, what do we know? Say it again. For every one serving, what's happening with our costs? What's happening every one serving?
The cost is for
For every one serving of food.
every one serving, your cost is going to let it go.
1.2.
2.
So we can say in this scenario, and we understand you need more work with slope, which we'll get. But we could say here that the slope is $1.25 for every one serving. So our slope is 125. How does that relate to the unit rate and the constant of proportionality? Not at your question. Mortimer.
Because that is your constant or your proportionality. Because basically the point that you're making with the slope is the same constant value that you're making with your unit.
Right. So our slope is the same thing as our unit rate, which is the same thing as our constant of proportionality. So those three values on the whiteboard, the constant of proportionality, the unit rate, and the slope, they are the same thing. You should know that. You need to know that. And if you don't know it, write it down. Because those three words, you will see them used interchangeably. They all represent the same value. It's how much you're growing for every one unit.
The constant of proportionality, the unit rate, and the slope,
Hold on, we've
they're
been doing it the
all
whole
the
class.
same thing.
They're the same.
Yep.
In
all
this
three of them are the
scenario,
same.
all three are 1.25.
So in this case, this is our slope, 1.25 for every one. So using the slope, we can go up 1.25 over 1 and find every single point on this line.
All right, let's go
Oh,
back.
now we
We're
have-
not ready.
Oh.
Hey, that was
So now we need to figure out, because you didn't get work with slope, we need to kind of go over that now. Right? You need to be able to graph an equation, right? Or graph a line. Now right here, you can pretty much do it without knowing slope, because if you're given a table, or even if you're just given a scenario, you can create a table. And from your table, you can put these points on the graph and then just draw a line. And I could write an equation based on that. Well, very quickly, we're going to go over this in more detail. The slope of a line. Okay? I don't know if this is in one other lesson, but I feel like we need to. We refer to it, just like Miss K said here. We're growing by 1.25 for every one. $1.25 for every one. So our slope, and you'll see this represented in multiple ways. Some people say rise over run. But it's really the change in y compared to the change in x. So in this scenario, we're growing 1.25 every one. That's how you recognize and identify your slope. Again, those are things you can write down because those are really, really great to go back to. And you'll see anchor charts as we really get into graphing, which we're not in the heavy part of graphing yet. But when we get there, you'll probably learn this again. But for those of you that can just see an equation and start to plot the points, this is really how you're getting there. And again, you'll see this again because we will get, especially in functions, we're going to do much more graphing. But this is kind of like the basis for it. And you'll kind of see how we get all of those values when we get there. Right? That's what's coming.
So now we're going to do a group activity. So we're splitting into groups of 3. Or the groups of 5.
So we have, you can be group. We prefer 3, so if those of you are in 4s, you can break off. You can go back to where you are after. See if like 2 of you can bounce over through each of the group. Because there's 3 things in each, just bounce over to a group that only has 2. You can go back right when we're done.